Unit 3, Lesson 3, Presenting a Problem for Problem-Based Learning. Note there are text and slides to support this presentation at www.archimedes2014.eu. Hong developed a model for presenting problem-based learning problems to learners. He named this the 3C, 3R model. In keeping with this model, we will look at the following in this lesson. The 3 C's refer to content, context, and connectedness. This identifies the way information will be presented in the problem. The 3 R's refer to research, reasoning, and reflecting. These are concerned with presenting components which encourage the learner to complete the problem-based learning process. Further reading of Hong's model can be accessed by clicking the below text. As mentioned previously, the 3 C's are concerned with the knowledge and content projected in the problem and how the individual might integrate it into other aspects of the problems. The content components focus on the ability of problem-based learning to cover breadth and depth of content. The problem must be presented in a way that directs the learner to the required content. Therefore, the problem must be presented to the correct level. When designing a problem in an organisational context, it is important to consider what is already known about the problem and what content can be given to the learners to enable them to address this problem. Is there sufficient information to allow the learner to solve the problem, and are enough facts known about the problem? This will depend on its clarity. For example, if a problem is concerned with attracting new customers, what past approaches have the organisation tried? What sectors do their main customers operate in? Hong emphasised the importance of specifying the scope of the problem when designing the content to guide and support learners. Context. The importance of context was discussed in the previous lesson. As mentioned, a problem can be taken from a number of contexts with a number of different solutions. In Hong's model, context emphasises the importance of authenticity of a problem to a given profession or discipline, as it improves the ability to retain and recall the knowledge constructed. In the workplace, there is less focus on discipline and more on the needs of the organisation. As mentioned, problem-based learning can allow a problem to be explored from a number of different contexts. If the context is important in a work environment, it must be specified in the problem design. If not, the ideal scenario after the problem has been solved must be specified. For example, what's the overall target? If you want to attract new customers, must there be a particular increase in the number of customers attracted or an increase in the number of sales? Connectedness. This relates to systems thinking in a learning culture, getting the learner to think of how the problem relates to other parts of the organisation. Hong refers to connectedness in the context of curricula being delivered as a series of problems. The problems must be interrelated to prevent the learner from compartmentalising their knowledge. By illustrating the connectedness between problems, it allows the learner to integrate the knowledge from different problems. There are different methods for doing this. Complexity. Increasing the complexity of the problem as the learner progresses through the curriculum. This was suggested in Unit 2, in which the complexity of the problem should increase as the self-directedness of the individual improves. Overlapping, referring to similar problems that were encountered previously or previous efforts to solve problems. This can be seen in an earlier example when we refer to previous efforts to attract customers that the organisation have completed. A multifaceted approach. Test ideas in different contexts. Within a company environment, this will be done anyway. It's expected each person in the problem-based learning group will have a different hypothesis depending on their role, and they will test these during self-study, and the optimum solution will be arrived at. In the problem presentation, it's important to refer to any similar problems that have been encountered or other efforts at solving these problems. The 3 R's. As mentioned previously, the 3 R's are concerned with the components which are presented in the problem required to ensure that the learner successfully engages in the problem-based learning process. Research involves outlining to the learner what is required from the problem-based learning process. by specifying the goals you expect them to attain throughout the process. These goals can be from an organisational and a personal perspective. In a study conducted by Petrosona 1998, it was found that students which received specific goals for the problem-based learning project illustrated a better understanding of the content they learned, as well as using a methodological approach to research and data collection. By articulating the goals of the problem-based learning process, it reduces the concerns students have with the ambiguity of problem-based learning. Within an organisational context, this might involve specifying in particular what you want the learners to examine, what do you want to achieve for the organisation, and what do you want the learners to achieve from a professional's perspective at the end of the process. For example, for the problem, how to export products to an Asian market without a physical presence, you might set the objectives for the learners to examine customer buying behaviour, excise and customs laws of the receiving countries, export and trading laws in the European Union, transport mediums, and distribution partners. The organisational objectives might be to increase sales to Asian countries by 10% in the next year, attract 20 new Asian customers, and set up 2 distribution channels to these customers. Reasoning. This involves encouraging the learner to apply what they've learned from research. In problem-based learning, the learners are required to analyse information, generate and test hypotheses, and put their knowledge to the test. Problems must be designed in a way that encourages the learner to apply reasoning techniques. For example, going back to the problem, how to export products to an Asian market without a physical presence, you might expand the objectives to encourage reasoning and application. This will contain verbs such as explore, research, apply, analyse, adopt, integrate. For example, explore the customer behaviour in Asian markets and determine how it might impact on the product we offer. Research the excise and customs laws of receiving countries and what feasible measures we need to implement in our organisation to satisfy these requirements. Reflecting. Reflection is a key part of problem-based learning and an aspect which builds critical thinking. It allows the learner to understand solutions they might have missed or approaches that might have made the learning process more effective. Usually, reflection in problem-based learning is done under the guidance of a facilitator. However, Hong states by building this element into the trigger or the problem design, it will encourage learners to be more independent and cultivate habits of the mind to reflect. When designing a problem for problem-based learning, it is important to articulate how you want the learner to reflect. Reflection can take place throughout the problem-based learning process, formative reflection at the end, or throughout, or summative reflection at the end. Through building in reflection, we can allow the learner to articulate their mental models throughout the process, which we spoke about as part of a learning culture in Unit 2. In addition, it can help companies understand the decision-making process undertaken, which can be applied to other similar problems. Hong suggests for formative reflection, ask the learner to record during each stage of the problem-based learning process if they have acquired the relevant knowledge that the problem-based learning problem requires, if they have studied the topic at the sufficient depth, what research methods they have used and if they are effective, what reasoning processes they have used and are they logical and effective, if they have integrated their knowledge conceptually, if their problem-solving strategies are effective. For summative evaluation, Hong recommends you ask the learner to examine the process of how they research the information related to the problem, the logic of how they linked the key points that led to their hypothesis and solutions, and any alternative hypotheses and solutions, the reason why you selected that solution, and how you would solve this problem differently if you were given a chance to start over. Also, any follow-up problems or questions. Click on the below link for further study on reflective learning. In the next lesson, we will look at categorising the problem.